Good morning, everybody. I'm sorry that I can't be in school today. I'm not feeling that great, but I just wanted to teach you the new lesson, which is Unit 6, Lesson 9, Exponential Growth Compounding Interest. So take a minute to read through the warm-up question. Most banks compound interest more than once a year. When interest is compounded n times per year for t years at an annual interest rate of r, the principal p grows to an amount a given by this formula. This is the formula that we talked about on Friday. Suppose you invest $1 in a savings account, so that's your p value, which pays 100% annual interest. So your rate is 100%. So if you take your percent value and divide by 100, that would mean that your rate is a 1. I want you to calculate each of the following questions that the do now question is asking. So parts A, B, C, D, E, F, and G. So pause the video and give those a try. Okay, so let's go over the do now. So first we'll start by taking a look at part A. What is the value of the account at the end of the year if the interest is compounded annually? Compounded annually means once a year, so your n value would be a 1. So my total amount is equal to my dollar times 1 plus my rate divided by my n value of a 1. Raised to my n value of a 1 times my time, which is 1. So I have 1 times 1 plus 1 to the 1. So 1 times 2 to the first power would give me $2. Now, what about if we took this value in the account at the end of the year and we compounded quarterly? So quarterly means 4 times per year. So A equals my dollar times 1 plus my rate of 100%. I'm compounding quarterly. So I'm dividing my rate by how often I'm compounding, and I'm multiplying my time by how often I'm compounding. So I get 1 times 1.25, or 1 plus a quarter, to the 4th. If I type that into the calculator, let's say 1.25 to the 4th power, I get $2.44. Okay, let's take a look at part C. So what's the value in the account at the end of the year if the interest is compounded monthly? So compounding monthly would mean 12 times a year. So I'm dividing my rate by 12 and multiplying my time by 12. And if I type that into the calculator, 1 plus 1/12 raised to the 12, I get $2.61. How about if I compounded weekly? So there are 52 weeks in a year. So dividing my rate by 52 and multiplying my time by 52. Type that value into my calculator. And I get $2.69. How about if I compounded daily? So there are 365 days in a year. So I'm dividing my rate by 365, multiplying my time by 365. Let's see what we get. $2.71. What if I compounded hourly? So there are 365 days in a year and 24 hours in one day. So if I take 365 and I multiply it by 24, I get 8,760. So I'm dividing my rate by 8,760, and I'm multiplying my time by 8,760. And let's see what we get. $2.72. So are you ever able to turn your initial investment of $1 into $3? So can you compound interest more throughout the year to make even more money than you did in part F? So the answer would be no. The more frequently you compound, right, even if you compound it as quickly as you could, every minute of every day, your amount of money would only reach 2.718281828. This number occurs so frequently in math that we give this value its own letter, and we call it E. So just like pi is equal to 3.14, on and on and on and on, E is equal to this number 2.718, on and on and on and on. And this number arises if you compound as quickly as you can. And if you looked at your calculator, let me just get it on here. The number E is second division sign. And then if you hit enter, you'll get your approximation. Okay. So if compounding takes place without interruption, we call that compounding continuously. That means we're compounding as fast as we possibly can. When we're compounding continuously, we use this formula A equals PE to the RT. So your base value is E. And E is really, remember, just equal to this number, about 2.718. So when you're using this formula, it's like saying your total amount equals your initial amount times this base of about 2.718 raised to your rate times your time. And your rate needs to be expressed as your decimal. So I want you to pause the video and I want you to try to answer exercise 1. Okay, so let's take a look at question 1. Kelly Ann has $20,000 to invest. She puts half of the money into an account that grows at an annual rate of 0.9% compounded monthly. Okay, so half of the money. So if she had $20,000, she's putting $10,000 into an account that grows at a rate of 0.9%. So 0.9 divided by 100 is 0.009. Compounded monthly. So our N value is at 12. So let's figure that out first. So A equals P times 1 plus R divided by N to the NT. So she puts $10,000 to the account. It was just Mrs. Carnes telling me she was going to upload the video for me. And let's see, to the T. They didn't give us a time. So A equals 10,000 times something to the 12T. And to get this value here, I'm going to type that into the calculator. So I have, let's get that decimal value. 1 plus, we would make a fraction, 0.009 divided by 12. So 1.00075. So I can already tell that the answer has to be choice 4 because that's the only part that would start out like that, but let's just double check. Let's read the second half of the question. At the same time, she puts the other half of the money into an account that grows continuously at an annual rate of 0.8%. So the other half of the money would mean the other $10,000. If it's growing continuously, my base is going to be E, an annual rate of 0.8%. So 0.8 divided by 100 is 0.008. So we have our other $10,000 growing continuously. So my base is E, my rate is 0.008, and my time, they didn't give us. So to figure out that second half of the question, we're using the formula A equals P E to the RT. And again, we're using that formula because they're talking about continuous compounding. Okay, take a moment to pause the video and to try exercise number 2. All right, let's take a look at our last question, question number 2. A population of 950 bacteria, okay, that's our p-value, our initial amount, grows continuously, so our base is going to be E, at a rate of 4.75% per day. So 4.75 divided by 100 means that my rate is 0.0475. Write an exponential function, n of t, so I have to use function notation, that represents the bacterial population T days, and explain your reason for the choice of your base. Okay, so N of T equals P E to the RT. Because we're compounding continuously, we're using this base E. Okay, so N of T, that really just means my Y value, is equal to my initial amount of 950 bacteria times base E to my rate, which is 0.0475 times my time. I chose base E because the bacteria are being, or I should say are growing continuously. Okay, sorry guys. Determine the bacterial population after 36 hours. Okay, now, let's see. 36 hours, they're telling me, but my rate is in days. So I have to think about how many days is 36 hours. Well, 24 hours is 1 day, right? So this would be 1.5 days. So I'm going to go to my formula. N of t equals 950 e to the 0.0475 t. And then for t, I'm going to plug in 1.5 here, 1.5 here. So n of 1.5 equals 950 e times 0.0475 times 1.5. So I'm replacing that t value with a 1.5. So if I type that into my calculator, I get 950 base e, and e I'm going to raise to the 0.0475 power, and I'm going to multiply that by the 1.5 days. So I get 1020.15 something something something, and because they said to the nearest bacteria, I get 1020. Please take a few minutes to try the practice. There are 9 practice questions, and the answers are at the end of the lesson for today. And homework for tonight is homework number 9. Hopefully I'll be back tomorrow, everybody. Have a good day.